This meeting is being recorded.
Oh, sorry, Kinir, about that, ne?
It's all right.
Okay, sorry, I'm really sorry about it. Okay. Sure. Okay. So now, okay, we're gonna be doing, like I said, today we're gonna be doing, we are doing functions and graph. And then, okay, actually, what I mean by a function is just, what I call this thing, it's just a set, or it's when you're given a set of values, which is X values, we call them inputs, and then you put them in an equation, and then it gives you the output, which is Y values. You understand? That's actually what is a function about. It's just you are given a set of X's, and then you want Y values, and then you work around with it. And then this is just an easier role of the diagram, putting in this in a simple form. So here you are given a set of X's, which is X values here. Then you put them in an equation straight towards, and then you get what Y values. And for example, you see, like I said, the X values are called the inputs, and the Y values are called the output values. For example, if you're given an equation which is Y is equal to 2X minus 1, which this is a straight line, you know that you're gonna be given an X value to get Y value. Nah? That's why we call that. That's why we call the Y value an output, because it's what you get after inserting X. And this diagram also make it easier. If you have like you take -1 and you put it here, you're gonna get -3. These ones are the X values, all of them, this one. And these ones on the side are gonna be Y values. And then this is just the row, which means it's the equation in a way. You understand?
Yes.
But okay, there's something you must, when you're working with functions, you're like the X values, the element, all of the X value sets, we call them domains. You understand? The X values, we call them domains. And also like the Y values, the sets where your graph lies on them, we call them ranges. You understand? And then, okay, like a true definition of a function, it's a relationship between the X and the Y values, where if for every X value, there's only one corresponding Y value. You understand? Which means if I have -2 as X, I mustn't get two things. You understand? I mustn't get two Y values. I must get only one Y value. That's how is it. That is a true definition of a function. If a person asks you what is a function, it's a relationship between the X values and the Y values, where for every single X values, there's only also Y corresponding Y value. One of it. It's 1:1. That's actually what is meant by a function, is a 1:1 ratio. Yeah? And then how, because not every graph that you're gonna come across is a function. That's one thing you must know. It's not every graph that you're gonna come across that is a function. How can you check that a graph is a function or not? We have something that we call vertical line test. Yeah? Vertical line test, it's a line that you draw that is parallel to the Y values, to the Y axis. It's parallel to the Y axis, and then you're gonna check if the graph cuts, if the line cuts your graph once, or if the line cuts your graph twice. You understand?
Yes, I do.
If a line drawn parallel to the Y-axis cut the graph only once, then the graph represent a function, which means a graph is a function. And if a parallel line drawn, if a line parallel drawn to the Y-axis, it cut the graph more than once, then that graph is not a function. You understand? The graph is not a function, which means all of the rules of the function don't include it, then they don't apply in them. Example here is we have graph A, which is what do you call this thing? A quadratic graph, and then we have graph B, which is a straight line, and also say a quadratic. If you look at the dotted line, that was what we call a vertical line test, the dotted line. If you look at graph A, it cuts the graph once. Understand? You see, cuts only the ones. If you look at graph B, also cut the graph ones. But when you look at graph C, it doesn't cut the graph once. It cuts how many times? Twice, which means graph C is not a function. So whatever rule that applies on the function graphs, it doesn't apply for C. You understand? Exactly. And then we have something called function notations. The function notation is just a way that maths created to make things easier when you're dealing with so many graphs. For example, they usually use f at x. F at x is more like is equal to y. It's more like y, f at x. Because they usually say, you see, they usually put it as in like f at x is equal to 2x minus 1, which is the same as y is equal to 2x minus 1. It's just that now we're giving that specific graph a name. So, okay, this is graph F, this is graph G, this is graph H. So there are also other notification that they use. You understand? You can use G at X, you can use F at X, you can use H at X, you can use T at X. It's up to you, or up to the person who's setting the questions. You understand? You can use anything, because once you say T into X, then we know that it stands for Y is equal to something. You understand? And also, let's say you can work it out. Let's just say if you're given a situation, they say you have X where they tell you that we want where X is equal to -3. You understand? We're still using this. We're still using what? We're still using this equation where f at x is equal to 2x minus 1. So we want to know in this equation, when x is -3, what will be the value of y? You understand? If we put, that's why this x, this -3 replace the x. That's just to mean, okay, we want x when it's 3, when it's -3. Then you just input -3 in your equation and then you get -7, which means when x is -3, y will be -7. You understand? So in your graph, there is this point that lies on this graph that you have. You understand? This is how the notation works. The function notation, this is how they work. There is no other way that they work. You understand? It's just, if you understand this, this just short summary, then you would understand what they mean by it. And then, okay, we have different type of graphs or type of functions. We have what we call a linear function. A linear function is just more like it's a straight line, where we have y is equal to mx plus c, or y is equal to ax plus b, or y is equal to ax plus q. It doesn't matter. As long as it doesn't have any, it's ax or it's mx or everything. Why is it there is only x power to anything? Then we know this is a straight line. Né? Okay. Q here, the q stands for what? Because it's f of x is equal to ax plus q. The a stands for a gradient and the q stands for y-intercept, where x is 0, which means wherever x, your x values or your x is 0 here in your y-axis. No matter even it's negative, like negative, your y is -million. If it's on the graph, or if it's on the y-axis, just know that your x is 0. Same thing as with your y-axis. If your graph is maybe even your x-axis value is -1000, but if you are talking about x-axis, then your y is 0. Right? You understand what I'm trying to say?
When like the x is 0, then
0 when your y-x values are y-axis. When everything that, if your graph cuts y-axis, just know there x is 0.
Okay.
And if I'm talking about the straight line though, I'm talking about the straight line. We're still gonna call, and then for y, also for when y is 0, it's when your graph cuts the x-axis. You understand? Here they cut at the origin, so both of the coordinates here, it's 0 to 0. You understand? Yeah. But if it was cutting here, then maybe let's just say it was cutting at 5 here. Then the coordinate was 5 is to 0. If it was cutting at -2 here, it was going to be -2 is to 0. But if it was cutting here at 10, then it was 0 is to 10. Even if it was cutting at -1,000 here, it was 0 is to -1,000, which means the y value is -1,000, but the x value is 0. You understand? Exactly. So for x-axis, if you just look, for when you look in your when you look at the graph, check the end points of the graph. If they have arrows like this one, which means they're continuing up until we don't know when. So we regard that as infinite. You understand?
Right.
Which means you remember that you remember when we started, I said the x-axis, we call them what's domains. The range is where your graph, the x-axis value where your graph lies, we call them domains. And then where your y value is where your graph lies, we call them the range. So the domain of this graph, because you understand that it continues up until negative what we don't know. And also it continues up until positive what we don't know. So the x-axis, which is the domain, is from -infinite to +infinite because we don't know where it ends. Because if you take maybe what do you call this thing? You take the equation. Let's check here. Y is equal to x. This is the equation of the graph. If here we put what do you call this thing? We put for x maybe usually, which is an input, we put -100. Our y will be also -100, which means for every x value there is a y value for this graph. You understand?
Yes.
So that's why it doesn't mean that it has to go on like on the x-axis. No, it has to continue wherever. When you put your x value, you get a y value. Unless if you put an x value, you don't get a y value. Then no, that is outside the range, outside your domain, which is x-axis. So for this equation, for this graph, the domain is from -infinite, which is signified by this, to +infinite, which is signified by this. You understand? Exactly. And then the range is the same thing also, because it still continues. If you put a y value, you're going to get an x value. So which means the range is also the same thing. The graph continues in the y values upward and also downward. So even the range is the same as the domain. You understand?
Yes.
Exactly. So the second graph, we're gonna look at the example after. So the second graph, we call it's a quadratic graph, a quadratic function, which is called a parabola. It has two like shapes. It's either faces down or faces upward. It won't face to the side, because once it faces to the side, it's gonna not be a function, because you remember when we are doing the thing, a function or no function, you saw that exactly it's gonna cut twice, then it's no longer a function. The usual equation of the quadratic function is ax² plus bx plus c, or it's y is equal to a into x plus p, x plus b squared plus q, which is probably the same thing, you understand? But the more used one is ax² plus bx plus c, which is an easier one. So the a is the gradient, you understand? If your gradient is negative, your graph faces downwards.
Oh, yes.
Yes. If your gradient is positive, your graph will face upwards. No other way around. You understand? There's no other way around. If your graph is facing downwards, that tells you about your A, which means your A has to be negative. If your graph faces upwards, that tells you that your A has to be positive. You get me?
Yes, I do.
You still with me? Okay. So, okay, the axis of symmetry is just, what do you call this thing? Let me just do this. Axis of symmetry is just when you separate your graph into half, yeah? Which means it's gonna be this point here. It's gonna be that x-axis value, understand? That is gonna be your what? That is gonna be your line of symmetry.
Okay.
That is what
that's gonna be on the turning point.
Yeah, on the I'm glad that you remember this the terminology. Yeah, the turning point. Yeah, the turning point. That's where your x, your line of symmetry, axis of symmetry, because axis of symmetry is where like we take a thing, we cut it into half, and it gives us a perfect double edges. You understand? It gives us a perfect mirror images, which means this mirror, even if you flip it to the other side, it stays the same. There's nothing. So that's what. Yeah, understand. And that this what do you call this thing? This x-axis value can be calculated using this equation, which is x is equal to minus b from the equation, from this equation. Eh?
Okay.
You understand? From this equation. And then you do that. So, and then b is this one here. And a is the gradient. That is here. You get.
I do. I get it.
Exactly. So, and then okay, so remove these things because you're gonna need the notes, so I don't want to make it. Okay, so yeah, so you understand with this one. And then the turning point is given by this equation. It's this equation. It's this not equation, sorry. It's what do you call this thing? It's what we call the coordinates of the turning point.
Yes.
Yeah, you see the x-axis, and the x-axis, the point of x-axis is the same as the one for x-axis of the turning point.
Right.
You understand? The axis of symmetry are the same as the x value of the turning point, which means, like I was saying, you just want the x value of here, and then you know that that one is the x coordinates of the turning point. And then after getting the turning point, you can just take your x and input it in the equation, and then you're gonna find your locus and your y value of the turning point. You see, they took this is it's more like this is an x. If this one is an x, and then this one is a f at x, which means here it's an x. You understand?
Right.
You get what I'm trying to say?
Can you just show me that again?
Okay, let me just remove this thing. Okay. Let me just show you. Okay. I want you to see that. Look at this axis of symmetry of the graph.
Yes,
it's
I can.
Minus over 2. It's the same as the x coordinates of the turning point.
Oh yes, yeah. I can see that.
So if you want the y coordinates of the turning point, the only thing you have to do is to take the x one and put it in the equation.
If I want the...
Okay, wait, let me show you something. So, sorry to cut you off. Look here. Look here. Okay, you remember x, if x is equal to 3, then that one was x into negative 3 is equal to 2x minus 1.
Minus 1, yeah.
It means wherever there is, oh, okay, wait. Let me just do this. Sorry, erase. Let me just do this. This is x, ne? So if they already told me that x must equal to negative 3, so f at negative 3 for my x is equal to 2 into negative 3 minus 1. You get okay. So in this equation, they didn't play it like that. This is our x. Our x here is going to be what? Negative b divided by 2a. You understand? So our f at x is the same as f into negative b into 2a.
All right. So you substitute the x value to get the y value.
Exactly. That's what actually is just saying this thing. You substitute the x values to get a y. That's what actually it's all about. It's just straightforward like that, ne? Don't get it confused. You're just gonna do like that. So you just substitute, you take the equation and substitute your x value, and then you get your y value. Let me just get this. You understand? So,
Yes,
and then they say the function may have either a maximum value or a minimum, but it can't have both. Obvious. It can't turn up and down at the same time. No. This is what I call the thing. This thing, they only act on the parabola or the quadratic function, not any other thing. They act here. These commandments or these statements. So when they say it has a maximum, which means it's this one. This is your maximum because your graph, the maximum thing, the graph that can go is this one. There's no above thing.
Yes.
Which means when your graph has a maximum, which means your gradient is negative, which means your graph is facing downward.
Oh.
You understand? When you have a minimum, which means your graph is facing upward, this is the minimum that the graph can go. It can't go beyond this. You understand?
Yes, I do.
Exactly. So, and the one that has a minimum is the one that if you had a minimum just now, your a is negative, which means this one. If he has a minimum, your a is positive, which gradient is positive. If you have a maximum, your a is negative, the gradient is negative. You understand?
Yeah.
Exactly. For a domain, it's the same thing. This domain, it's only place for these two shapes, not the other shapes, these two shapes. Your domain is from negative infinity. Sorry, I forgot to write the negative here. It's from negative infinity because it continues, which means for every x, it's still gonna continue, né? Yeah, well, it's more like if your Cartesian plane here. You see, it continues for x up until even, which means it still continue for x up until the last part. Exactly. Up until the point that we don't know. And also, even on the other side, it's going to continue up until the point we don't know. Because look at the end, like I told you, remember, it has arrows, which means it's continuing, it's not stopping. Yes, if it had a full stop, then which means it ends there. You understand?
Oh,
the same thing.
And there are two, just a minute there. No. There are two full stops there. There's this one that has a space in between, and there's this one that has like it's black inside. So I just don't understand the difference between the two. If you could just touch on that.
No, okay. I'm gonna touch on them later when I'm done telling you. Like when we're doing what do you call this thing? When we're doing the equation, not the equation, the exercises, so that you can tell students can know when to yeah. Okay. Oh, let me just talk about it now. Okay. Let me just talk about it when I still remember. Okay, the pen. Okay, you have a graph that is like this. Okay, let me just use this one. Yeah. Okay. Erase. I just wanna let you know. Okay, you have a graph that is like this, but instead of this one, it's shaded like this. You know?
Yes.
The shaded part. Oh shit! Sorry. Okay. Okay, what is going on now? Oh, so. Okay, so the pen is no longer working. Oh, yes. The shaded parts, if you write, what do you call this thing? If you write your domain, which means that point is included, that's where it stops. Let me tell you something. Let's just say, we have these two and these two, you understand? Okay, it cuts here and also cuts here. And then here, let's just say it's negative 10. And then here, let's just say it's negative, it's positive 4. You understand?
Yes.
If you write a domain of this, because it has full stops, like the field one, the domain is going to be from negative 10 to what? Not the domain there. Yeah, the domain, yeah, the x-axis.
Yes.
From -10 to +4. That's a domain. You understand? This is the domain for this one. And also the range, it has to from here up until the last part. You understand? But
the range,
okay, let me just erase this so that okay.
And then okay, with the brackets as well. I did currently those brackets that are inclusive and not. So with the dots, the shaded dots, it's not included.
Oh yes, yeah. No, the shaded dot is inclusive. Okay, let me just write it the way you want it. You see, if you were writing that one, oh yes, thank you for highlighting the bracket things. The shaded dots, you use this bracket.
Okay.
Which is inclusive from -10 to 4. You understand? But when it's not okay, let me just say okay, pen. When it's you don't use this one.
Oh, okay.
-10 to 4. If you don't write it like this, if you want to write it in a different way, you can say okay, let me see. Okay, it's more like x is between -10. Oh, sorry. Is -10 to 4. This one is for this one, for exclusive one. But for inclusive one, you're gonna say x is between equal to -10 to 4. You understand? Look at this one. This one has plus, which means that point is included. You understand? That point is included. That's why we have a plus in the but this one is just less than, which means it can't be equal to -10. It has to be maybe 9.8 or 9.1. What you understand?
I do.
Do you understand now, Wano?
I do. Thank you so much.
No problem. The pleasure is all mine. Let me just erase this thing so that you will get the proper notes. Okay. Okay. Oh, so yeah. Okay, so yes, days. So yeah, but here's the problem that comes with this one. It's the range. The range is about what do you call this thing? The range is about the y values. You remember that the range is about y values.
It is, yes.
So, yeah. So what is going to happen is that the range for this one, all of your y values has to be less than the x value of the turning, less than the y value of a turning point, because the y value of the turning point is the last one. You understand? They have to be this one. It's more like it's this one. Let me show you. It's this. This one is for this one. And this one is for this one. You understand?
The minimum, the one that has a minimum.
Yes, like look at the arrows that I drew. This one is for this one. You understand? Why I'm saying that is because look, if you look, they say here y has to be, which means the y values where you graph has to be less than the y values of the turning point. The y value of a turning point. You understand? Because you remember this is a y value of a turning point. You understand? Okay. So this one has to be less than, which means this is the highest peak. There are no more y values up after this. So the y values, the range will start from -infinite to 0. You understand? If it was 0 like this, but if it was in a way like this, If it was maybe like this is gonna be thing, and then it's like this. Maybe here it's oh, let me see. Maybe here is what? It's -5. Then your domain was from -infinite to 5. From -infinite to -5. You understand? Because the last y value of a turning point is the maximum one. You can't go above it. You understand?
I do.
Exactly. So even here, if you look at this one, specifically this one, they say y values has to be greater than the y value of a turning point.
Yes.
So here's your y value of the turning point. Here's your y value of the turning point. All of these y values, all of these ones, they're above this minimum. So to say your range can't go beyond this point, and your range here even can't go beyond this point. Has to be lower than this point. Here they have to be higher than this point. You get what I'm trying to say?
I do.
Exactly. Thank you very much. So I can move forward now. Ne? You understand everything that I explained with the parabol.
I get it. Thank you.
Okay. Lazy. Okay. Oh, and then we have the third graph function, which is a hyperbola. Hyperbola, it's more like what do you call this thing? It's more like it's two half graphs that have a mirror image. You understand? Like for this one, this is more like you took this and then you just mirror image to get this one. The same thing as this one. You just took this one, you mirror image to get this one. Right. Okay, hyperbola is in a form of y is equal to a over x. You understand? It has to be a over x. You understand me?
Yes.
Or xy is equal to a. But one thing you must know for fx that a can't be 0, can't be equal to 0, and x can't be equal to 0, and y can't be equal to 0. So which means we can't have zeros in this thing. Okay. In this, we can't have 0 in this, what do you call this thing? In this equation. What can we do now when things are like this? Okay. If your a, oh sorry, it got cut by mistake. If your a is greater, listen carefully. If your a is greater than 0, then your graph will occupy the first quadrant and the third quadrant. You understand me?
I do.
First and a third, if a is bigger, which means your gradient is positive. You understand me? If your gradient is negative, which means a is less than 0, your graph is going to occupy the second and the fourth one. You understand?
I do.
Exactly. So the domain for this one is the domain. The domain for this one is just from -infinite to +infinite. It's the same as a straight line. You understand? The domain. But it's the same thing. But it can't be equal to 0. I don't know why I forgot to write this thing here. But it can't be equal to 0. You understand? Because you don't get your graph here on 0. It won't touch it. It's just gonna come close to 0, but it won't, your graphs here, they won't touch your 0 here. I understand?
Okay.
Same thing with the range. The range is from -infinite to +infinite, but your y can't be 0, which means it doesn't include 0. It can be 0,00001, which is not 0, but it won't touch the x-axis or the y-axis. So even here, sorry, I made a mistake here. I was supposed to write the same thing as here.
It's okay. So just a little question, like, that is when the asymptote is 0, right?
Yes. That's when when your graph is like this, but when the asymptote is not 0, then
it can.
Then you can write it like that. But now it's only the number that is here. The number that is here is your asymptote. The number that are here. These are your asymptotes. If your asymptote is 9 and 2, then here you're gonna have 9, you're gonna have 2.
It can never be equal to, yeah.
Exactly. I like your first line. I like that you catch up so fast. It's good to work with people like you. Okay. So, and then like they said here, the asymptote is the x-axis, which is the x-axis here, and the vertical asymptote is the y-axis. That's why I said it can't be equal to 0 for both of them. You understand?
Yes.
And then the line of symmetry is, for this one is y is equal to x. For this one is y is equal to negative x.
Okay.
Yeah. Like, and then we have the fourth one, if I'm not mistaken, the fourth one, which is the exponential one. The exponential one is just one curve. It's more like a hyperbola, but only one curve now. You understand? And that curve can expand to two of the first quadrant. It's either this one or this one, or this one or this one. Doesn't matter. Or both of these or both. Doesn't matter which one. You understand? Mm-hmm. And the equation for exponential is y is equal to ab into x plus q, or plus p plus q. P, it's what do you call this thing? It's or q is this one, which is the y-intercept, the q. Mm-hmm. You understand? And x is when maybe it cuts. When it cuts, what do you call this thing? When you cut your x-axis, which is not usually the point, but sometimes it do cut x-axis, then you just move it. This is just for say it moved upwards 2 times or it moved downwards 1 time. You understand? Okay. Yeah. Maybe it was abx plus 1, which means it moved upwards, which means this one will no longer be 1. It will be 2 now because it moved 1 point up. You understand?
Right. So the q determines the horizontal shift.
No, the q determine the y-intercept, this q. Let me just do this. There is a q and a p. Yeah. Wait, which one? Oh, yeah. The q and the p. The p determine the shifting. The vertical, the shifting, it goes up or go down. The shifting.
Okay, the p.
The p is a shifting, and all this one, which is the q, determine the intercept.
How?
You understand? The y-intercepts, where it cuts the y's. No. I'm the one making mistakes also. So this one is for x when shifted x or y. Yeah, I'm the one who making mistake. This one here, because it's along with the x, which means x. The x. Your graph shifted to the left by 1 or what, or your graph shifted to the right. And then this one is the y-intercept, which is this one. Okay. You understand? Yeah, no, sorry, I made a mistake. I was not paying attention. So yeah, that is the your obvious. They say if your b is greater than 1, you understand? Mm-hmm. If your b is greater than 1, then your graph is gonna just be like this, which is the same. Which is the same thing when it's between 0 and 1. But when it's less than 1, it's gonna face downwards. You understand? When it's less than 1, if your b is or your a is less than 1, then it's gonna face downwards. It's more like you put a mirror image in this part, and then it face downwards. But we're gonna come across those things. And then we have this one, which is called you understood the one that we just came from?
The exponential, yes. Okay.
Yeah, okay. And then there is this one called the inverse function. The inverse function, It's where you take, maybe you're given this, let me just do it. Maybe you're given this line, this graph, and you wanna find an inverse of this one. You just take the y values, you convert them, and with the x values, you convert them to a y value. You take your y values here, you convert them to the x value. This is y here, this is x here. This is x here, this is y here. You understand? It's more like you take the y values and you change them to x values, and you take the x values, you change them to y values. Then you're gonna you take your range you make it a domain. You take your domain, you make it a range. Okay. That's the inverse is all about. Yeah, this is the inverse. Inverse is just all about that. You just taking the inverse and stuff. Okay, obvious. The reflection axis of symmetry is y is equal to, most of the time it's always going to be this one. Y is equal to x. Y is equal to x. That is your axis of symmetry most of the time. So there are some situations where it's not always like this, but most of the time it's like this. Nah? Okay. And then obvious. Now the function notation of an inverse, you write it like this. Don't make a mistake. The f into the power -1. Understand? That means that if, let's just say, this one was f at x is equal to 2x plus 6. Ne? Sorry for the handwriting. This one will be f into x minus, oh no. I mean, now I'm making a mistake now. Don't write it like this. Pen. Okay. Is equal to half x minus 3. You understand? This thing here shows that this one is the inverse of this one. You understand? Which means you can move from this one to this side, you can move from this. That's why I wrote arrows on both sides. This one can move this way. This one can also move this way, which means you can move from this equation going this side. You can move from this equation going this side again. You understand? Because both of them are what we call the inverses, which means if the another part of me is just the inverse part. It's more like this is a good part, this is a bad part, but both of them are one person. You understand?
Right.
Yeah, you get me. Thank you. If you understand, that is a good thing. Okay, so yeah, I don't know if okay, but and then there is a logarithm function. The logarithm function is more like exponential. It's just that now we're using the log. You understand? You can.
Okay. Okay.
It's more like, what? Okay. There's something here. Do you want to say?
Oh no, I said I need to pay attention to this because I'm not very good at this, but yeah.
Okay, so the log function, this logarithm is the same as the exponential. It's just that here we use log. You understand? That's what is the difference. The other one is just a common one. This one is a log. So what do we do? What happens here? You say y is equal to log xa, which is just the equation how we put this thing. You see, this is how they also put it here. Y is equal to log 2x. And then with the function of a is equal to log number and x is equal to log base. That is actually about. So actually you're gonna say y is equal to log a base, and then actually this is just telling you what you call this thing, how to like get this one. But we're still gonna do an examples of these things that I'm teaching. I don't think we're gonna be able to do calculus today. I don't know if we have a problem with that. We can even try it tomorrow.
I didn't get this one.
No, I'm saying I don't think we're gonna be able to do calculus today. we're gonna do it tomorrow if you don't have a problem.
No problem. We just focus on it.
Okay. So actually, then here they say exponential. You see, exponential equation can be written as logarithm equation, and also the logarithm equation can be written as an exponential equation. This is just to show you that both of these things are the same. It's just that the other one uses log, the other one doesn't use log. You understand?
Which one uses log? Exponential.
The logarithm. That's why they call it logarithm, because it uses log. But this is the same thing as the exponential. It's just that the reason why we call it a logarithm now is because we included log in the equation. It's still the same as the exponential. It's just that now we're working with log. That's what I'm trying to say.
So logs are functions on their own. I cannot say that a log is an exponential. A log is a function on its own. Yeah, it's a logarithm is the function, because you see, if you wanna rewrite this, it's gonna be y is equal to 2x. 2 to the power x, yeah. And then it's not gonna be like this. Your graph is not gonna be like, it's gonna be kind of way like so. You understand? So that's why. Wait, so I can say that exponential, that a log function is an inverse of an exponential.
No, it can't be an inverse. It's not an inverse per se, because an inverse is something. No, it's not an inverse.
Okay, but now if you say, if you say that this function, this one, y is equals to log 2 to the power x, is that how I say it?
Yeah, it's y is equal to log 2x, not 2 to
log
the power.
2x.
It's just log 2x, and then log 2. It's log base 2x.
Oh, log base 2x. Okay.
It's log
so
base,
you say,
which our base, and then the x.
Okay, sorry. I'm sorry for the lingo.
No, it's fine.
You said it could be written as y is equals to 2 to the power x.
Okay, let me. Okay. Okay. No. Okay. Wait. I just wanna show you something. Okay. Wait. Google. No, I just wanna show you something. So I want to show you how you take the other thing to the other one. Okay, I think it's rule 5. Just want to show you what I mean, but because that thing you can work it out actually. You see, it's more like an inverse. You understand? Look, you see, it's what this one is y is equal to a to the power x. I think you can say, I think you can say these are more like inverses. Okay. Yeah, no, you say, yeah, you can say, because you see, this one is y is equal to log a into x. Then this one is like y is equal to a to the power x. And if you look at them, they are kind of an inverse thing. So yeah, I think they are inverse. Okay. Yeah. So, okay. Okay. Yes. So yeah, we can say they are inverses. So, and then okay. I don't know if there's something that you want to know.
Let me just.
We're gonna go to the what do you call this thing? We're gonna go to the exercises now on how you attack when they say this, how you attack when they say one. Do we have any? Okay. Oh, instead with the linear, we're gonna do it like we started with the linear, so even here we're gonna start with the linear, continue like that. You understand?
No problem.
Okay. Here's the problem. They said first you are given this thing. Obvious, you have two. Okay, look at this number one, the graph.
Yes.
This is straight. They gave you 1 point, which is what at there?
1 is
they gave
to
you 1 is to 1. But they didn't give you 1 point, they gave you 2 points. Can you see that? They gave you 2 points.
Oh, yes. The other one is 0 and 2.
The other one is what? No.
0 and 2.
No, this one is an origin. This one is
2 and 0. Sorry.
Yes. This one
2 and 0.
Is to 0 because there is no y.
Right. Sorry.
This one here. No, it's fine. It's fine. Just be sure that you don't make that mistake when you're writing because it can cost you an entire thing.
Right.
Yeah. Just make sure, please, because I want you to. Okay. This point here. This one is to 0. You understand? So, and from this one, you can work, what do you call this thing? You can work your gradient. You know how to calculate the gradient of a straight line, eh?
I do. Let me try. So it's going to be y2 minus y1 over x2 minus x1.
Exactly.
Sure. Okay.
And then you're gonna get your thing. Okay, let me do this now. Okay, skip the implementations. We're gonna go back to them. Okay, I'm sorry, I couldn't just put them on the. You understand? Here's the thing. Okay. Fit the width. Here's it. You understand? Y2 minus y1, x2 minus x2. You can make anyone, even if you can this is gonna be 0.2, this is gonna be 0.1. It's up to you. Ne? It's up to you. It's up to you. So here they made the one that they were given y2, and then this one was y1. And they got their answer is A is 1. And you see, one thing I must tell you is that if your gradient is positive, which means your graph is gonna go this way.
Oh, right. Okay.
Here is it. I'm sorry, I didn't. Here is it here. You see, this one is facing this direction. Okay, let me just, I want a pen actually. Come on, you can't give me a pen. Oh, shit. Okay, but yes. See, this one. No. Doesn't work like this one. Okay. It doesn't want to do what I'm. Oh, you see, it's the pen. Sorry. The pen. Oh, okay. Doesn't want to do the thing that I want to do. Okay, but yeah, you see, if it like this way, close, yes. So if it's facing this way, which means it's negative, your gradient is negative this way, which means you can just, I don't know if you can see me, like, but you can use the right and left.
Okay.
Your hands. Yeah, when your gradient or your A is negative, you use your right hand facing this direction. If your A is positive, you use your left hand, which means your graph must face that direction of the left. You understand me?
Okay.
Exactly. Yeah. So yes. I want you to understand that. So yes. You can see here. Okay, if we calculate, we got A, which A is what is bigger than 0. You can see that the graph is facing this direction. You understand? It's facing this way. This one, if we calculate it, here you are given this point, and which one?
Sorry? Here.
Which,
Oh,
yeah, so,
and 0 and 0.
Exactly, this one. So by the look of it, your graph is facing this direction. When you look at the graph, what is telling, what can you say about A? The value of
A. A is the gradient.
Yes, A is the gradient. So
oh, I usually use M, but okay. So with
okay,
this
okay.
one,
Okay, let's just say M. Let's just M. So not to confuse you. Let's just say
with
M.
this one, the gradient is negative.
Exactly. You understand your thing. If it's positive, you use this direction. If it's negative, you use the other one.
Okay.
What the hell? Okay. It doesn't want to remove these notations anymore. Okay. Okay, so yes. Here they tell you determine the gradient. We already determine which is gonna be negative. It's gonna be negative, ne? The gradients are gonna be negative. Where is the memo? Yes, okay. Yes. See, okay, here. The gradient is positive, this one. The gradient is negative, this one. From there, because we know that it's y is equal to ms plus c. Yeah, understand? You can just, for a or ax, for you, it's gonna be m. Just put this one here and then you make for y-intercepts, you look at, if you calculate for y-intercept, you let your y, talking about y, ne? You let, if you calculate your y-intercept, you're gonna let your x be 0. If you calculate the y-intercept, you're gonna let your x be 0. Do you understand? The y-intercept, x is 0. For x-intercept, y is 0. But here we are not calculating for x-intercept. You understand? You just, you're gonna put, your equation is gonna be like this. From there, you're just gonna take this point they gave you, which is -1 and 1. You put them here, and then you calculate, and then you get this equation. You understand? It's positive, which means it faces the other direction. Here, it's like this, which means, here is just, they made a mistake here. It's 0, which means your x here is just negative 2x. Your equation here doesn't have this x, ne?
Okay.
Yes. Okay. Then they didn't say substitute the values, and then this is what we did. We already done all of this. And then with this one, and then we have the parabola now. You understand? The parabola is about what? It's okay. You are given, or they told you that A, B, and C are the intercepts of the graph. And then they were like, determine the coordinates of A, B, and C. Wait, no, I think there is a missing information here about the graph. Wait, let me check. Yeah, there's a missing information here. Is there missing information? Oh, yes. Oh, the equation, yeah, the equation of the graph. This is the equation. You see, if you rewrite this equation, let me just copy it and paste it here so that it will be easier. Okay. Oh, okay. This, okay. Okay, so if you look at this equation is the same as f at x is equal to negative x squared minus x minus 2, or plus 2, the end. Oh, sorry, yes, I drew. Okay, I say negative x squared minus x plus 2. You understand? This is the same as this thing. I'm just putting it in the way of ab squared plus ax squared plus b squared plus c. You understand? And then which means my a is equal to -1. My b is equal to -1. My c is equal to 2. You understand?
Yes.
Exactly. So the last part, this one, the C, is it's always, you see this last part? It's the what? It's this, it's the y-intercept. So the point for B is 2, it's 0.
And 2.
Sorry. Yes. It's 0 is 2. Here, but for these ones, you remember when I told you, actually A, B, and C are the intercepts. You understand? If I say intercept, which means that if you want the y-intercept, you can say let the x equal to 0. If you want to this one. If you want the y-intercept, you say let x, but if you want the x, you say let y because. But now we're looking for 1 and 2, which is what are these two? These are x-intercepts, ne? So what we're gonna say let x and y is equal to 0 because we're looking for x. You understand?
Yes.
Oh, shit. Yes. Okay. So what we're gonna have now is gonna have negative x squared minus x plus 2 is equal to 0. We transfer all of this thing that side. We're going to have x squared plus x minus 2 is equal to 0. And then you can use the quadratic equation that x is equal to plus or minus. Wait, is plus or minus what the equation?
You are asking.
Minus b? No, it's fine. It's fine. It's what? And then it's b squared minus 4ac. Yes. Divided by 2a.
2a, okay.
Yes. And then you just, because I already told you your b is -1, so you're going to include your -1 here. And then your b here also -1 squared minus 4ac, which means your a is -1, your c is 2. And you're going to, let me just put them in the calculator and tell you what I'm going to get. It's, okay, 4. Okay, and the quadratic equation. Okay, the quadratic equation has to be the okay. Let me just say 3. Okay, it's It's gonna be x. No. Alphabet x squared. No, it's negative x squared minus alphabet x plus 2. Okay. Shit. I don't remember how we do this thing using, let me just see 3.
I can help you. What do you need?
No, I wanted, I got this thing. I wanted to use the calculator, but let me just do the usual way.
Okay.
Okay.
I got the first ready to be -2.
Oh, okay.
When
let me just check. Oh, no. Wait, I made a mistake here in this equation. Yeah, that makes sense. Here, it's it's b plus or minus.
It's minus. Minus.
It's minus b
plus or minus. Yes.
Okay. Thanks. So and then square roots. The inside one is fine, eh?
Yes, the inside one is okay.
Okay, it's correct. Okay, so it's 1 squared. Oh shit. Okay, we're gonna have 1 squared minus 4 into 1. Oh, -1. Wait, or B, or I chose the first one. Yeah. Wait. the B, if I say minus B, then, oh, it's gonna be positive, this one. So, the B is, it's 1 plus -1, and then, okay, yes, A is also -1. My C is 2. And then 2, okay, wait. 2, let's just, what is wrong with this calculator? 2 into -1. Yes, the first one is -2. Then the second one is 1. So we already got the coordinates. This one is -2 is to 0. This one is 1 is to 0. You understand?
Yeah.
So we got what they wanted. Anyways, we got what they wanted with this one, which are the coordinates. So we have all of the coordinates already. You understand?
Okay, so I just
sorry? Yeah, you just equate those x values and then you are done.
Okay, so I equate the entire equation to 0. X becomes
if you want the for y values, you can just put for y values we let x equal to 0. You understand? If you want y. So if you put 0 here and 0 here, obviously you're gonna be left with 2. So you already 0 is to 2. You understand? Yeah. If we put 0 here and then it makes sense. And then they say determine the turning point of the coordinates of the turning point. You understand?
Yes.
You remember that's the, what do you call this thing? Okay, you remember that the equation for x value of a turning point was -b over 2a.
Yes, I do.
Which means -b, we have -1 into, negative into -1 divided by 2 into -1. So the x value for a, this is 1, this is half, look at this, it's gonna be, or the x value is gonna be -half, which is this one here, which means here I have -half is to what? Then I just take the equation and put 2 minus into -half minus into -half squared. I get what? I get 9/4, which is 2,25. Which is 9/4. You understand? So I have my things. So I have that coordinates already. If I have that one, I move. Now they say write down the equation of the axis of symmetry, which is the axis of symmetry is this line. You understand? If they say write down, you see the straight line like this facing upward. It's only gonna take it's only gonna have the x-axis, which is what? I'm gonna have -half, exactly.
So x is equal to negative.
Exactly. That's it. Because we don't have y.
Okay. If we had y, what was it going to be?
No, it's if it was had y, it was gonna cross like that. No, wait, let me check this. What do you call this thing? Discard. Okay. Let me. Here is it. It's y is equal to. Oh, which one are we doing? Okay. Yes, you see, half and 9/4. So now, yes, it's because it only cuts is what the x-axis is. It's parallel to the y-axis. So the only thing it's x is equal to 9/4 or x is equal to 2,25 or half, like they did here. You understand? And then now they say determine the x values, the values of x for which negative. You understand? You must read like carefully this. Which negative effect is less than Okay, let me just put it on corner so that we can do it. Look at this thing. Now, you see here, they are smart in a way. They want you to be smart, you understand? They say negative f at x, where is greater than 0. You understand? They are not talking about this graph. This is f at x, but negative f at x, which means we multiply everything by negative. So if we multiply everything by negative, we're going to have f at x, and it is equal to
negative
x squared minus x plus 2. But this one, x, sorry, is equal to what? X squared plus x minus 2.
Oh.
You understand? Now it change, which means it's going to flip upside down. That's what they did here. It's just flip it upside down.
Change A. Okay.
But here is one thing they are not smart about this. When they want the x values will still be same, would be, let me see. Oh, if we flip it now like this, I'm gonna flip it by 2. You see? Yes, it's x will be less or greater equal to 2, or x is greater or equal to 1. Which means if we flip this graph, we're gonna have to determine the turning points now again. You understand? You determine the turning point, which means that one is gonna be from negative infinite to that point of x-axis, and then from the another one going up there. Or if you don't want to write it like this, because I feel like these ones are gonna be our coordinates for the what do you call this thing, for the bottom one. You can just from negative infinity to positive infinity. But since they gave you 2 marks, I think they want it like this. You understand what I'm trying to say? Okay. A and B. Okay, read the question carefully. We want when f at x is less than 0. You understand?
Yes.
When our f and x is less than 0, this is what actually they mean. They want it when it's below the x-axis. Okay, let me try. Here's the graph now. It's no longer like this. It's gonna be like this. When your graph is less than 0, they want this.
Below the x-axis.
Yes. So it's from this side. If it's less than 0, from this side to this side.
Okay.
If it's above, here they say want it above than 0. It's from this side going this way, which means going this way. And from this side going that way, above 0. You understand? They say they want your entire graph where it's above 0, which means you're in this graph above x-axis 0, which is above here. So we from here to that side, from here to that side. You understand? But if they wanted the range, it was gonna from negative infinity to positive infinity. You understand? Or you want me to play it again?
Okay. So I don't understand when you say it's from. Can you just explain when it's greater than 0?
When they say now, okay, I want you to understand this thing. What they did here, they said they want the entire graph.
When it's less than 0.
When it's greater, no, this is greater.
Okay.
When it's greater than 0, which means when the graph is above the x-axis, which is this part, because obviously they decided to put this one. So here, they want this part when it's greater than 0. That's why they said, okay, let me just show you this one. This card. That's why here they said from -2, it must be less than -2 and be greater than 1. Those ones are the x. Those ones are the x-intercepts. You remember? Those ones. If you flip it upside down, the x-intercept, they will still remain the same. They won't change because we didn't shift it.
We just flipped. Okay.
Yeah, it's more like you just decided to put a mirror here on the x-axis and then you flip it upside down. But these x-axis, they're still gonna be the same. They don't change. So you understand?
I do.
Okay. And then there is this what do you call this thing? We have the hyperbola. Hyperbolic with hyperbola, yeah. Hyperbola, like I said, is the one that is 1 over x, the one that on the sides is either on the second and the third, or the first and third, or the second and the fourth. You remember?
I do remember.
Now, they gave you this, exactly this. And now they said what? Determine y is equal to 1 over x negative 2. And then, or minus 2. They were like, now determine the equation of the asymptotes. I want, okay, let me just, since it's gonna be easier when you're doing like this, so that you would understand also. Oh yes, determine the equation of the asymptotes. Firstly, the equation, which is what
the asymptotes. Okay.
Sorry?
Because
yeah. Yes,
can
the
I
equation what? Oh, sorry. Yeah, I'm listening.
Oh, I wanted to try and give you the answer.
Oh, you want to try it first? Yeah, you can try.
Okay, because there is no value by x, then it's gonna be the first asymptote is gonna be x is equals to 0. The second asymptote is gonna be y is equals to negative 2.
Thank you. Just like this. The horizontal one is y is equal to 1, and then the other one is y is equal to 1. You understand?
Okay. Yes.
And then the second one was like determine the x-intercept. What you're gonna do when you determine the x-intercept?
I am going to say y to make y equals to 0.
Exactly, just solve the equation. And then after that, you are good to go. Yeah, after solving, after letting the y equal to 0, it's going to be 0 is equal to 1 over x minus 2. You just transfer the x, the 2, the side is going to be 1 over x is equal to 2. And then you just cross multiply and then you are done. And then you sketch your graph. I want you to understand me. I want to hear something from you. Now, just tell me about the quadrants. It's the first, second, third, and fourth. Where is your graph is going to lie?
Okay, because it's going to be in the first and the third quadrant.
Very good. That's it. You understand? It's just easy like that. So after that, and then they say write down the range and the domain.
Okay.
No, I'm here now. They say write down the range and the domain.
Okay.
Right. Just tell me the range and the domain.
The domain is gonna be from negative infinity to positive infinity.
You know the domain is yes.
Yes, and then the range is gonna be.
This is not complete. That's not complete.
It's not.
No, it's from negative infinity to positive infinity. But does it touch 0? No, it doesn't.
Oh no, where x is never equal to 0, right?
Exactly. And the range.
And then, okay, let me think about this. The range is gonna be. Okay. Okay, the range is gonna be from negative infinity to positive infinity, where y is never equal to -2.
Thank
Is that
you.
right? Is it? Oh,
Exactly.
yeah. Okay.
Yeah, like you're catching up very good. It's exactly like that. Then you see, you are done with that one. Now you understand. Let's go to 9. Except for exercise sets, let y is equal to 0, you solve it, and then you get your x, which is half. You understand? But then the second part, which is, where is it? 1.3. Oh, this is 2.1. And then the other part, there is like draw it. Here is your thing. Draw the first and the second. But the first and the third. And then there's a domain. This thing is the same as like from -infinity to positive infinity, but it doesn't equal to 0. You understand? Even here, but it doesn't equal to what? So, or they made a mistake. Yeah, they make a mistake here. They say 2, but it's supposed to be -2.
Okay.
Yeah. And then from there, the B, they were like, what did they say for B?
I didn't get the question.
Oh, the line of symmetry in the form of y is equal to x, y is equal to x plus c, or y is equal to -x plus c. Then what you do is the same thing. Axis of symmetry, you just translate to downside. Okay, no. Y is equal to x and y is equal to -x. The thing that you, okay, no, it's fine. I'm gonna show you the easier way of doing this shit. This is the easier way of doing this one. You just take, you want the, what do you call this thing? You want the axis of symmetry. You understand? If you want the axis of symmetry, so you want your y is equal to, it's y is equal to x minus what? You understand? Or you want to put your axis of the axis of symmetry in this form. They told you want to put in this form, this one. So which means we're calculating what? We're calculating c, because we know it's going to be y is equal to x plus what, which means it shifted twice, or it moved down twice, or it moved up twice. You understand? We know that the last is what is -2, the y, which means definitely it has to cut here in -2, because it was cutting as 0, né? It's 0 here, but now it's no longer going to cut. It's going to cut at -2. So you can just write, there's no need for all of these things. You can just write y is equal to x minus 2. You understand? Just write it. And also in this form, just y is equal to -x minus 2, and then you solve, and then y is going to be. You understand? Yeah, you get me?
So
actually,
y is equal to -2.
This one, because here we're talking about line of symmetry. It's either it's gonna be in here or here. It's both of them are gonna be line of symmetry. Let me show you what I mean by line of symmetry. You understand? It's either line of symmetry can be like this or can be like this. So they want to know if all of them line of symmetry in these both forms. So they want to know how they are going to be.
Can you just explain using this diagram? Like
what?
To say, because this one is now, the asymptote there is -2. Okay. How am I going to formulate the equation?
No, you just, okay. Let me. You see, this side is equal to this side. So for this one, you can just put your axis of symmetry here. Understand? Or you can put it like this, like they put it here. Forget about this one. I'm not talking about this one. Forget about it. I'm talking about this one. If you put a line here, you're gonna get the same the total thing, the same completion. Understand? It's gonna be the same shape. If you put your mirror here, it's gonna be this thing is gonna be the same as this one. And if you put your mirror here, this side is gonna be the same as this one. That's why we have 2 types of symmetries. You understand me now? That's why here we have these 2 and this one. We have 2 lines of symmetries. It's either izokhatha here, ku-2 in this form of the negative one. You understand? Negative gradient, which is going to be this one, line of symmetry. But if it cuts this the other way around, it's going to be which one? This one.
Okay.
You understand? So now you understand?
Yes, I do. Thank you.
Okay, no problem. And then, okay, yeah, that's how things are. And then, we're going to the exponential now. Okay, the exponential. Okay, they gave you or they gave you this point and that point. You were told that the curve of the exponential function is given by f at x is equal to kx. You understand? I think the x is an exponent. No, the x is an exponent. Yeah, sorry, I didn't write it. I think the x is an exponent here. And then it cuts y-x is at a, and then 0 is to 1, which means this point is 0 to 1. And then b into 2 is to 9 over 2. Okay, then let's just go to this to it here so that you're gonna be able not make you more confused than you are already. Okay, now the activities. Okay, oh yes, it's yeah. You see, this x is an exponent. I made a mistake there. Sorry. Understand? So what are they saying? They say determine the equation of this one. You understand? Same thing. You are given this. If you are given this, what are we looking for? You can get it. First of all, the gradient. We want to know what our k in the form. Okay. Here is it. So they know it's 9 over 2 is equal to a squared, which is this one. The b, which is the here. You understand? They say f at x is equal to k at x. And then 9 over 4. I think this one is 9 over 4, yes. Okay, let me show you, let me remind you a small thing here. Let me remind you a small thing about the exponential. Okay, you see, the graph was, no. I think, where is that showing you how to draw? Oh, okay, I think you just do this, but it's kind of pointless. It's just a lot of work. Plotting like this, it's a lot of work because we want to get the k first. Okay. Okay, let's look at this one, the example. Yeah, see, you are given the point A. Point A is what they say it's write down the coordinates of A. Coordinates of A, it's 1, yes. It's A, 0 is to 1, ne? Yeah, given. So if you wanna, if like you already have the coordinates of this one. So if you wanna get A, you can get it by substituting the coordinates of this one here. You understand? The y coordinates is what? Is 1. The x coordinates is 0. So you can get A. What is your A? You understand?
Yes, I can.
Which means you can just use the logarithm or what you understand. And then, so here's what they did here. He took this point, which is B, and then you substituted with it in the equation and solved the equation. But the one that we're doing is this one. Let me show you. Even in this one, they did the same thing. They took this point, which is here, because B, x will be 0, and then it would not be solved. So they took B, which is 2 into 9 over 4. They substituted here with it, which is 9 over 4 is y, and then k and a is the same thing, and then x they substitute by 2. So what they did, they're trying to make 9 over 2 into something to the power 2 so that they can just remove the exponent and equate the bases, you understand? So what they do, you just use the square root on both sides and then you cancel the square. You have this one. So which means the equation is going to be f at x is equal to 3 over 2x. You get me?
Okay.
The first thing we were calculating k, which is the same thing as a. So that's how they did it. They say f at x is equal to k at x. And then they took the coordinate that doesn't have a 0, because once you have a 0, things will not be solved easily. So they took a coordinate that has both numbers, and then they substituted it, and then they decided they got their thing here. And then equation 2, they say they determine the equation of the asymptote of h if h at x is equal to minus f at x. So which means this equation, now it has a minus. You understand? If it has a minus, now if it already has a minus x, so we times this thing by negative, all of it. This one has to be times by. So it's good. The f at x, negative f at x is now going to be negative 3 over 2 into power x. You understand?
Mm-hmm.
So, which is what is still going to be 0, because we just times it. We times we times it by negative, which is more like you just change the gradient, the way it's. Oh shit! The way it shapes. You see, this one is gonna be a negative. Where is this thing? Your a is between 0 and 1. You understand?
Okay.
You understand?
So when it's between 0 and 1, it faces.
Exactly. But when it's what they do? When it's greater than 1, it faces this direction. But now, since this one is negative, they didn't draw it here. But since this one is now the h at x, this one is negative. The h at x is gonna change what? It's gonna change the direction. It's gonna flip downsided. Now it's gonna face down. It's not gonna face up. You understand? It's no longer gonna be like this. It's gonna facing downward. Because
why? Because
now it's the a or the k is less than 0.
Then it faces down.
It faces downward. You get what I'm trying to say? You get? Okay.
Yes, I do.
Look at this one. No, look at this one. You see, here, this a or the k, yeah, the a here is between 0 and 1. Doesn't equal to 0, it doesn't equal to 1. It's between them, yeah, understand?
Yes.
But if it's greater than 1, the graph is gonna face like this. You understand? Now, if it does put a negative, it flips downwards. You understand? It's gonna face downwards. But the same thing still applies. It's just that now it's on a negative side, which means it's on a lower side of the x-axis.
Okay.
You understand? Exactly. So what you're gonna have here is still gonna be the asymptote is still gonna be what? It's still gonna remain as 0. And then the range of y now, the range, everything that is less than, you see, less than or equal to 0, which means it faces what? Downwards now. It is not facing upward. It faces downward. So and you also see here, this graph is started from the origin, started from the x-axis exactly, not just close to its x-axis exactly. It touches the x-axis. So your gradient, and not the gradient, sorry, your range is gonna free from 0 going downwards, moving from 0 to negative infinity. You understand?
Yes.
So that's why they said here, your y has to be less than or equal to 0. You understand me? You understand?
I understand, yes.
Okay, let me just try and draw it for you so you can see. Okay, the new graph will be like this now. Oh, sorry, but it started on the x-axis, it will be like this. This will be the new graph, né? The one This one is going to be h at x now, no longer f at x. You get me? So if now it's like this, the range, the y values start at 0 going downward. So that's why they say y value has to be less than or equal to 0, which means from 0 to negative infinite. You understand? That's, or from negative infinite, you don't write it like this. You don't write it like this because we write the lowest first. So your thing is gonna be from negative infinite. No, negative infinite is not 8. It's gonna be to 0. That is what you call the range of this one, the range. But the domain is gonna be from negative infinite to positive infinite because it's still the same thing. You understand? Yeah. Then the equation of the curve G, which okay, wait. Okay, I don't think it's good. Okay. And then here they were like the equation of the function G of the equation of the function G of which the curve is reflected of the curve of x in a line of y's. So now what basically they are saying is that what would be the equation of the new graph if it's reflected by this line. Yeah, by this line, which means it's gonna exactly. That's what they want. They want the inverse. So what you're gonna have now, since this is 1, now it's gonna cut here. It's gonna cut here. Now it's gonna be like this. Now this was y, ne? Now it's gonna be x. This was y, so now it's gonna be like this. You understand?
Okay.
So it's gonna cut the same part this side. And then you just calculate the thing. Okay, let me show you the answers. This cut. You see? Now it's a what?
It's a log.
Exactly. Which means the log is the inverse of the exponential. You understand? Exactly. Then you have it. We are done with the thing. And then let's go to the thing, or there are 2 last ones, yes. And then our session will be off. Okay, and then for the inverse functions, okay, this is an exponential thing, which is the same as the other one. You understand? Let me just use this one. I'm still gonna put what do you call this thing? Okay.
The slides.
Yeah, I'm still gonna put the answers on the slide so that you will have an understanding.
That would be great. I would be.
Yeah. Okay, so here's it. Which one did I take for? Oh, here's it. Here's it. They say if f at x is equal to negative 3x squared, write down the equation for the inverse function in a form of y is equal to. Now, you wanna write it in a form of what? In a form of an inverse. If you inverse this is how they write it. You understand? You just swipe f and x and y. The easier way. I'm teaching you the easier way, ne?
Yes.
So you take if you're already given the equation, you just take this equation and swap x and y. So now it's gonna be x is equal to 3y squared, negative 3y squared. And then you just solve for y. Which means now your thing would be like square root. It's minus x over 3 into the power half. You understand?
So it's negative x. Okay.
Yeah, it's negative x over 3 to the power half. You understand? Exactly. And then they say write down the domain and the range for f at x and f at b. This, I think you need to draw this one first. You can draw it and then Yeah, you can just draw it so that you can be able. So the domain, because the first one, what we're dealing with is the, what do you call this thing? This is a parabola, because it's a quadratic, which means it's the one that goes, which the negative sign is facing downwards, né? Which means the domain for it, f at x, this first one, the one that we were given. The domain for it, the domain is going to be from negative infinite to positive infinite. But the range is going to be from negative infinite to 0, or to 0, because it cuts from negative infinite to 0. Understand?
But it's negative. So that means it's from up there.
Oh, okay. No. Yeah, I know. I made a mistake. So yes, facing downwards, né? So your y value is gonna be, if it face downwards, then yeah, the y value is gonna
be from 0 to negative to infinity, positive infinity.
Yeah. Okay. Exactly. That's the okay. And then no. Wait. Oh, yeah, the range has to be. I'm looking at x. What the hell is wrong with me? So because the first done, the y has to be greater than 0. Yeah. And then for f at x, now what you do, you just flip these things because it's an inverse. Now the range is gonna be the domain. The domain is gonna be the range. You understand?
Oh, right. Okay.
It's the inverse. The one domain becomes another one range. Another range becomes another one domain. That's it.
That's beautiful.
Yeah, and then they'll be like determine the points of intersection of f at x. And okay, let me tell you the easier way to get the points of intersection. If you have if you have two graphs and you want the point of intersection, you just take their equation and equate them.
Oh, okay. I equate the equations.
This one, see, you got negative 3x squared is equal to negative, the square root negative x over 3. You are done.
I solve them simultaneously.
Exactly. You do your thing. You do your thing here. Let me see what they did here. Okay, here they just
when I solve them simultaneously, I'm gonna get the x value, and then I go back and substitute that x value
in one of the equations.
Okay.
It's better to substitute in the one that you are given, and then you're gonna get the thing.
Okay.
And then you get your things, and then you move on stuff. Now you get what you want, and then you have your things. You can try it out though after this. And then number 2, they were like, if g at x is equal to 3x plus 2, find g into the negative x. Okay. The same thing, you just substitute x and y. This is y, this is x. You just substitute this one. So now it's going to be x is equal to 3y plus 2. And then you transfer things where I think, yeah, exactly. Now it's going to be x is equal to 3y plus 2. You substitute until you get your equation. Here's your equation. From there, and then the black sketch g and x, and then x is of x symmetry. Here they sketch them. This is the sketching, this is the sketching, and then you are done. You understand? Exactly. So, and then now we're going to be doing what? The logarithm. The log thing is still the same as the other one. Let me just take one thing. Okay, here's the activity for F. So you're given, let me see if it's the same. Oh yes, so you're given the graph, which is h is equal to h at x is equal to ax is sketched below, which is this exponential, and a is on the point. Then explain y coordinates. The coordinates as 0 and 1. I think this is just because this is what you call the y-intercept. So obviously, you understand. Let's say here, if you put 0 here, it's 1, which means h is cut at 1. Any place, yeah, 9. And then the number 2, they calculate the value of a. Write down the equation for the inverse function in a form of h at x. So what you're gonna do here, we're going to look for a first. What we do, we're going to take this point and substitute in this equation. Our y will be half, and then a into power -1. Exactly. We got the a, so if we got the a, and then y is equal to 2x. 2 to the power x. You understand? And then now we're looking at what do we want now? We want the inverse. The inverse is going to be what? A log. So the inverse will be like y is equal to log 2x. Exactly. Understand? If you want an inverse of an exponential, just put log and then put this 2 to be a base there, and then done. You understand?
Oh, wow. Okay. So
that's the easiest way.
In front of them. I make 2 the base and x.
And then x, it becomes like this, exactly. And then number 3, draw the sketch of what you just draw the sketch, which is going to be like this. Here you had, okay, here's you had -1 is to half. Now it's going to be half into -1. Oh, no,
okay.
they didn't put it here. They didn't put it, but this one now is going to be half is to -1, which is going to be here. And then this one is 0 is to 1, now it's going to be 1 is to 0. Okay. But you can do it any way you like. And then they will like read off the graph the values of x from O, which listen to this one now. I want you to listen to this one. Read off from your graph the values of x for which the inverse is less than -1, which means where the inverse is less than -1.
Where the inverse
is less than -1, which means it's this part.
Is below.
You understand? Yes, from this one going down, which means it's this side. Where my graph is less than -1, which means it's only this side. So it's from -infinite, it's -1. Let me see. Oh yeah. You see, my x's has to be, no, they say less, they have to be greater than -1, which means it's above. They say greater. So I read this one. Yeah, it's greater, yeah. So which means from 0,5, because this is 1, you see from 0,5, here it's starting increase, so x must be greater than 0,5. Then you have your thing. Then you're good to go. That's it. And then now after that one, these are answers I was trying to put them for you. So yeah, that's things are. And then I think I can just stop sharing for now. Stop sharing. Okay. Sorry for taking too much time like this. I hope. Yeah. If you have any, like, if maybe you go through them tonight and then you have any problem, just let me know. And also, like, if you have people let you know that maybe suffering for, even though not people that are from varsity, even maybe you have kids that you know back at home or where, then they need help. Yeah, like you can just refer them to me, and then, or you can refer them to me, and then I would just send them to the high ups, and then they're gonna fix them for a space for them. And also, even if a person is here, I think you sign up using the website, ne?
I did, yes.
So you can just also refer the people that are in university who need help with maths and stuff, or who still want to improve also. You can refer them to the website, and then they sign. And because we want to make sure that the aim is not making money, the aim is to make sure that the future generation and also our generation are moving forward. So okay, they must stop. Okay, yeah.